A very good morning, friends. Today, for the Unit 3 of Systems and Mechanical Engineering, we are going to see about the internal combustion engine, the basics of internal combustion engine. So here we go. Okay, so what does the internal combustion is all about? The internal combustion engine is something, it's a heat engine that converts the chemical energy that is stored in the fuel, and that energy is utilized and it is converted into mechanical energy. That right from the figure we can see the chemical energy, then the heat, and then from the heat the mechanical energy is being utilized. Okay, it is being converted to mechanical energy, the energy from the fuels. This thermal energy raises the temperature and pressure of the gases within the engine, and the high pressure gas then expands against the mechanical mechanisms of the engine. This expansion is converted by the mechanical linkages of the engine to a rotating crankshaft, which is the output of the engine. Basically, whatever the chemical energy that is being used, that is being stored in the fuels, that is utilized to get transformation into work energy, and due to the presence of the linkages in the different forms in the engines, that energy is utilized for the working of the internal combustion engine. So this is the internal combustion engines are basically the reciprocating engines having pistons that reciprocate back and forth in cylinders internally within the engine. Back and forth, that is the movement is back and forth, right? Okay. So these are the also are known as the reciprocating engines. There is certain basic terminology that we need to understand first. The what does the IC stands for? It stands for the internal combustion. Then this SI stands for the spark ignition, an engine in which the combustion process in its cycle is started by the use of a spark plug. Similarly, what is CI engine? It is nothing but the compression ignition engine, an engine in which the combustion process starts when the air fuel mixture self ignites. Air fuel mixture is used and it self ignites due to the high temperature in the combustion chamber caused by the high compression. Then there are certain other terminologies: TDC, BDC. TDC is nothing but the top dead center, the position of the piston when it stops at the farthest point away from the crankshaft. Okay, at the topmost position where the piston stops is called as the top dead center. And similarly, vice versa, when the position of the piston when it stops at the point closest to the crankshaft, that is at the bottom side, then it is called as a bottom dead center. And there is the direct injection, fuel injection into the main combustion chamber of an engine. The directly injected, the fuel is injected. And indirect injection is something, IDI. Also, it can be explained as the fuel injection into the secondary chamber of an engine with a divided combustion chamber. Okay. What is bore? Bore is something, the diameter of the cylinder or the diameter of the piston face. Okay, the piston face is having certain diameter that is explained as a bore, which is the same minus a very small clearance. Okay, a very small clearance is there. Okay. So next thing is regarding the stroke, the movement distance of the piston from one extreme position of the to the other. Okay, stroke is something what the movement or the distance of the piston from one extreme position to the other. Okay, so it might be from TDC to BDC or BDC to TDC, top dead center to bottom dead center, or bottom dead center to top dead center. That is called as a stroke. Clearance volume, minimum volume in the combustion chamber with the piston at TDC. When the piston reaches at the top dead center, the minimum or the minimal volume, or that the space or vacant space that is remaining, that volume is known as the clearance volume. Displacement of the displacement volume, volume displaced by the piston as it travels through one stroke. Through one stroke, as we have seen, what is a stroke? When the piston moves from top dead center to bottom dead center, or bottom dead center to top dead center, that is called as the stroke. And the volume which is displaced by that one movement or by that one stroke is called as the displacement volume. Smart engine, engine with the computer controls that regulate the operating characteristics, is known as smart engine. Then there is the air fuel ratio, ratio of mass of air to mass of fuel input to the engine. Fuel air ratio is something, ratio of mass of fuel to mass of air input into engine. Ignition delay is something, the time interval between the ignition in ignition initiation and the actual start of combustion. Okay, the time interval or the time delay between the ignition initiation and the actual start of the combustion. Next thing is regarding the basic engine cycles for the four strokes spark ignition engine, and that is compression ignition engine. For the four stroke engine, first we'll say what are the four strokes that are being carried out when during the first stroke, that is the intake stroke, it is also called as, or the induction stroke. The piston travels from the top dead center to the bottom dead center with the intake valve open. The intake valve is open and the piston travels from top dead center, okay, from the first position to the next position, that is the bottom dead center, and the exhaust valve is remains closed at that time. Only the intake valve is open. This creates what? This creates an increasing volume in the combustion chamber, which in turn creates a vacuum. Second thing is regarding the second stroke, that is compression. When the piston reaches the bottom dead center, when it travels from top dead center, it reaches to the bottom dead center, and during that movement, the intake valve closes. Intake valve is closed, and the position travels. And the piston travels back to the top dead center with all valves closed. This compresses the air fuel mixture, raising both the pressure and temperature. Now, in this stroke, what does happen? The air fuel mixture is compressed, and it raises the temperature as well as the pressure in the cylinder. Combustion of the air fuel mixture occurs in a very short but finite length of time within the piston near top dead center. That is nearly constant volume combustion. Then the third stroke is nothing but the expansion stroke or the power stroke, which is also known as a power stroke. With all valves closed, both the valves are closed, and the high pressure created by the combustion process pushes the piston away from the top dead center. Okay, and this is the stroke which produces the work output of the engine cycle. Exhaust blowdown is something late in the power stroke. The exhaust valve is opened and the exhaust blowdown occurs. The fourth stroke is nothing but the exhaust stroke. By the time the piston reaches the bottom dead center, the exhaust blowdown is complete, but the cylinder is still full of exhaust gases at approximately atmospheric pressure. Okay, so in the first stroke, what does happen? The inlet valve is open, the outlet valve is closed, the piston travels from top dead center to bottom dead center with the initiation of air fuel mixture. Then in the second stroke, the compression stroke, the piston reaches the bottom dead center. Since it has been reached in the first stroke, it has reached from top dead center to bottom dead center. And then in the second stroke, the intake valve is closed and the piston travels back to the top dead center. So it compresses the air fuel mixture. In the third stroke, that is the expansion stroke, with both the valves closed, again, the high pressure is created by the combustion process as the piston moves from the top dead center. And in this stroke, the work output of the engine cycle is produced. And during the fourth stroke, the piston reaches the bottom dead center and exhausts. The blowdown is complete, but the cylinder is full of exhaust gases at approximately atmospheric temperature, and at that time the outlet valve is open. So this is nothing but the internal combustion engine. How does it work? In the figure A, we can see displacement volume, the top dead center to the bottom dead center, the volume which has been displaced within that first stroke. What is the clearance volume in figure B? We can see, and the actual four stroke spark ignition engine, the figure is shown. The compression stroke is shown, the power stroke is shown in second figure. In third figure, the exhaust stroke is shown, and again in the last figure, the intake stroke is shown. Okay, so this is how the actual four stroke spark ignition engine is there. Similarly, the four-stroke combustion in the compression in the combustion engine, we can see that first stroke in the intake stroke, the same as that of the intake stroke in an SI engine that we have seen earlier. The second stroke is nothing but the compression engine. Again, the same thing happens. The compression, that is from bottom dead center to top dead center, the piston travels and compresses the air fuel mixture or the mixture. Then the combustion process is fully developed at the top dead center, and it continues at constant pressure until the fuel injection is complete and the piston has started towards the bottom dead center. Similarly, the third stroke is nothing but the power stroke. The power stroke continues as the combustion ends and the piston travels towards the bottom dead center. Exhaust blowdown, it is same as we have seen in the earlier case of the SI engine. Fourth stroke, that is the exhaust stroke, it is again same as with an SI engine. The four stroke SI and the four stroke CI engine cycle we have seen over here. Similarly, the two-stroke SI engine cycle combustion with the piston at the top dead center, combustion occurs very quickly, raising the temperature and the pressure to peak values almost at constant volume. First stroke, that is the expansion stroke or the power stroke, it will be here only that is observed that here only the expansion stroke or the power stroke is observed. Very high pressure created by the combustion process forces the piston down in the power stroke. The expanding volume of the combustion chamber causes the pressure and the temperature to to decrease as the piston travels towards the bottom dead center. Okay, so here the first stroke is fully of the expansion stroke, or you can say it as a power stroke. The exhaust blow down at about a 75-degree to the BDC, bottom dead center. The exhaust valve opens and the blow down occurs. The exhaust valve may be a poppet valve in the cylinder head, or it may be a slot in the side of the cylinder, which is uncovered as the piston approaches the bottom dead center. Similarly, in the intake and the scavenging is something what we can see when blowdown is nearly complete at about 50-degree to that is the position of the crankshaft 50-degree at the bottom right side. The intake slot on the side of the cylinder is uncovered, and the intake air fuel enters under the pressure. Second stroke is nothing but the compression stroke with all valves or the ports, that is both valves, intake and the outlet valves, are closed. The piston travels towards the top dead center and compresses the air fuel mixture to a high pressure and the temperature near the end of the compression stroke. The spark plug is fitted by the time and the piston gets to the IDC. The combustion occurs and the next engine cycle begins. So here is we can observe in the figures, that is how does the internal combustion, that is a two-stroke SI engine operating cycle is carried out. The crankcase compression is there in the first figure. We can see the power or the expansion stroke is carried out. Then in the second figure, that is the B figure, we can see the exhaust blowdown, how does it is carried out. And in the third, and that is in the C figure, the cylinder scavenging or the rest of the gases are being means taken means they are given out when intake port opens and the air fuel is forced into the cylinder under pressure. Intake mixture pushes some of the remaining exhaust gases. Okay, that is called as the scavenging effect. The remaining exhaust gases out the open the exhaust out the exhaust ports. The scavenging lasts until the piston passes the bottom dead center and closes intake and the exhaust ports. Okay, so next D figure is about the compression stroke. Piston moves from bottom dead center to top dead center with all ports closed. And last E figure is regarding the combustion at almost constant volume near top dead center. So this is nothing about the now two-stroke CI engine. The two-stroke cycle for a CI engine is similar to that of the SI engine, except for the two changes. Okay, there are two changes. The cycle is completely similar as that of the SI engine, two-stroke SI engine. Only there are two changes that we have to briefly see. No fuel is added into the incoming air, so that the compression is done in an air is done on air only. And instead of spark plug, what they have provided, a fuel injector is provided, located in the cylinder. And this is what the difference that we have to consider in the some small changes that we have to consider while studying the two-stroke CI engine. So this is just a brief and the proper brief introductory part for the basics of the internal combustion engine, and in details we are going to of course see in the coming our theory lecture. Thank you so much, and have a nice day.